Okay, first idea. We're going to talk about an oblique triangle. What does oblique triangle mean? Oblique triangles. Yes, you can either have all angles, right? All angles less than 90 degrees, or you could have two acute angles, and one obtuse angle, and so it would look something like that. Or you could have this one, which is like all 60, 60, 60, 60, so equilateral triangle. Or you could have all less than 90. And here's how the book sets it up, okay? The book sets up a oblique triangle as following, okay? If this is A, then the angle that's opposite A is going to be our alpha. If this is B, then the angle that's opposite our B is going to be our beta. And if this is C, since we no longer have a right triangle anymore, we have to say we have a new angle. We're going to call that gamma, right? This little symbol for gamma. So we have alpha, beta, and gamma. And alpha plus beta plus gamma, plus gamma has to equal 180 degrees always, because it's a triangle after all. All right? There are four possibilities here. There are four possible cases to consider when you have an oblique triangle situations. Okay? When you're comparing these things. You could have the situation where, one, you have a angle, side angle, or side angle, angle comparison happens. Okay? You could be given those two things. You could be given angle, side, side. Watch out for that one. Which is also known as the ambiguous case. It's the only time of the year I can get away with writing that. Ambiguous case, which is what we're going to talk about. Remember back in geometry how you could not use angle, side, side to prove two triangles were congruent, and you never knew quite why? Today we talk about why that is. It's called the ambiguous case, and it's a very important idea. The third one is you could be given side, angle, side for oblique triangles. And the fourth one could be side, side, side. Okay, if you have the first two cases here, angle, side, angle, or angle, side, side, you're dealing with the law of sines. Okay, and that's what we're going to hit today. That's all today's stuff. If you have these two cases, side, angle, side, or side, 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 then you're dealing with the law of cosines, which we'll get into on Friday, it looks like. Okay? So today we're going to focus on the law of sines and these possible situations and the ambiguous case. So these two things we're talking about today. So far so good? Yeah? Okay, so let's talk about what is the law of sines then. Second idea. The law of sines. Here's what it says. If you have an oblique triangle, A, alpha, B, beta, C, gamma, then the law of sines says the sine of alpha divided by A is equal to the sine of beta divided by B equals to the sine of gamma divided by C. All it is a bunch of ratios and proportions set equal to each other. And you can choose any one of those that you'd like to. The only thing you can't do is mix and match. So what I mean by that is, like, we could set sine alpha over A equal to sine gamma over C. Or sine alpha over A equal to sine beta over B. We could even invert the whole thing. We could put the A's, the B's, and the C's on top, and all the sines on the bottom. What you can't do is just mix and match them. Like, say, for example, sine alpha over A equals B over sine beta. You can't do that part. But you can leave everything else, either all the signs on the top or all the signs on the bottom, and vice versa. It's actually very, very handy. Okay, so let me give you a really dry, straightforward example, and then we'll go into some more interesting things. So let's say the book is always going to say solve this triangle. They're going to give you some information. They're going to say something like to the effect of A is equal to 4, B is equal to, we don't know, C is equal to, we don't know, alpha is equal to 40 degrees, beta is equal to 60 degrees, and gamma is, we're not sure yet, but we're going to get it. So they're going to give you the information, and they're going to expect you to solve the triangle, which means to get all of these things together. So can we easily get this one right here? Yeah, what would that one be? 80. Yeah, we can get that one because we just subtract off from 180 from the other stuff, right? From the angles in the triangle. Okay, then we make a little sketch here. So here's our sketch. We know this is 4, then this has to be 40. If this is B, then this part has to be 60. And if this is C, then this part has to be 80. So far, so good? All right. Then from the sketch, we use the law sign. So we're going to use this pair here because it's given to us. And we're going to say, well, I know that the sine of 40 degrees divided by 4 has to be, then I can choose either one of these two. I'll choose this middle one. The sine of 60 degrees, all divided by B. And I can solve this for B. So I'm going to say B times the sine of 40 equals 4 times the sine of 60. And then, of course, we're just going to divide out by the sine of 40. Divide out by the sine of 40. You guys follow along so far? So B has to be 4 times the sine 60 divided by sine 40. And I need 3 people to verify what the answer is. What is 4 times the sine of 60 divided by the sine of 40? We're going to round to 2 decimal places. I have one person that says 5.39. I have 3 other people that say 5.39. So we're going with that. 5.39. Sweet. So we come back up here, and now we know that B is 5.39. What's the only other thing that we need? C. Exactly. We're going to do the exact same thing.
Why can't you just press that theorem?
Because that's not a right triangle. That's a really good question, right? Everyone that says the same thing. Well, why can't we use Pythagorean theorem? Well, because it's not a right triangle, we don't know what it is, okay? It's an oblique triangle. So then we're going to say the sine of 40 degrees divided by 4 equals the sine of, what was the other angle that we found? 80, right? 80 degrees divided by C. So I can skip ahead and I realize that C is going to have to be 4 times the sine of 80 degrees all divided by the sine of 40 degrees. So C must be something. All right, can someone help me out? A couple people verify. What is C going to have to be? 6.13, 6.13, 6.13. So we're thinking that this has to be 6.13. So we go back up to the top and we say this is 6.13, and therefore now we have solved. All right, we're going to talk about the ambiguous case for the rest of the day here. You use the, so whenever you have, it's kind of funny here, you must consider the ambiguous case whenever you have angle side side. Okay? Whenever you have angle side side, so bad. Whenever you have angle side side, you have to consider the ambiguous case. All right? Side side angle. There we go. I can't handle it. Okay, side side angle. You have to consider this. Okay, and here's what could happen. Because there are 3 possibilities that can jump out of the ambiguous case when you're dealing with side, side, side. 1, you could either have one triangle exists. Okay? That's the normal thing that happens. You have one triangle. 2, you could have no triangles exist. That's the easiest thing to happen. Easy. There. And the third thing is you could have 2 triangles exist. And that's the bummer. And the reason that's the bummer is because it is more work. It's double the work because you have 2 triangles that exist, okay? So what I'm going to do for you guys is I'm going to give you an example of each. I'm going to start with the bummer example and work our way back to the easiest one. So we'll do an example of the ambiguous case with 2 triangles, the ambiguous case with 1, and the ambiguous case with none. And you'll see how I teach it, okay? I teach it different than the book teaches it. So if you want to read the book, which I know you do every night, you'll find out that my way is a little bit different than what theirs has. So just follow along here. Okay, so here we go. This is an example of 2 triangles existing. for the ambiguous case. Ambiguous case. So here's the information given to us. Okay? They're going to tell us that A is equal to 12 feet. B is equal to 31 feet. And C is equal to, we don't know yet. On the angle side, we have alpha is equal to 20.5 degrees. Beta is equal to, I don't know. And gamma is equal to, I don't know. That is gamma, right? Is there any physics people out there? I don't know. Is that right? I think that's gamma. It's not lambda, I know that one. I think it's gamma. Okay, if I'm wrong, I'm sorry to the whole math community. Yeah. Okay, so here's what we do. Here's how I approach these. I make a sketch first. So here's my sketch. If this is 12, this is 20.5. If this is 31, this is some beta. I don't know what it is yet. And if this is C, then this is that gamma thing, which I don't know yet either. So a lot of unknowns. So here is the thinking behind this. I know that there's 180 degrees total for every single triangle, correct? Okay, how much have I already used in this particular triangle? 20.5 degrees taken, correct? So how much is left over? Calculator, help me out. 179.0. No, that can't be. 159.5 degrees left over. You guys with me on that part? Okay, so this is the key to understanding why there are two triangles, because we have quite a bit left over. So that means between the two leftover angles that I have, this angle here and this angle here, somewhere there has to be a sum of 159.5 degrees, right? Because it can't be any more and it can't be any less. You guys feel me on that part? Okay, now we go back over here and we set up the only law of sines that we possibly can. This one and this one, because we don't know anything about the bottom two, correct? So we say this. We say the sine of 20.5 degrees divided by 12 equals the sine of beta divided by 31. Yeah, still follow along? So that means that 12 times the sine of beta has to be 31 times the sine of 20.5 degrees. And our goal is to get beta, so I'm going to divide by 12. Divide by 12. So the sine of beta must be 31, or this stuff in the calculator. So someone help me out and tell me, what is this answer in the calculator? 31 times the sine of 20.5 divided by 12. 0.90. Let's go to 3 decimal places. 0.90 what? 0.905. Do we agree? 0.905? Okay, good. Now, how do I get beta if the sine of beta is 0.905? Very good. So this says beta must be the inverse sine of 0.905. And tell me what you get when you do that. 64.8 degrees. 64.8 degrees. Okay, now watch what I'm going to do next. Or 180 minus 64.8 degrees. What does that give me? 115.2 degrees. Okay, now hold on, time out. Why do we have all these two angles here? Why all of a sudden do I have this one? Well, this one's pretty straightforward, right? Because we saw inverse sine of 9.905. But wait, why is this one here? Because it is the angle in the second quadrant whose sine is 0.905. Okay, let me show you what I mean by this. There are two examples there are two angles that out there in the world whose sine is 0.905. Here's the first one. Not that. That's not right. If I take the inverse sine of, if I take the sine of 64.8, look what I get. There's that 0.905 again, right? But check this out. If I also take the sine of 115.8, 0.2, look, I get this same angle, matching it up.
Why did the calculator spit out 60?
The calculator gives you the angle in the first quadrant. Okay? The 115 is the angle in the second quadrant, isn't it? It's past 90. So, sugar, there are two angles whose sine is 0.905. And here's how you know there's two. 64.8. Is that less than the leftover? It sure is, right? 115.2. Is that less than the leftover? It sure is. So you could have these two possible cases going on, right? You can imagine that in the case of only there being one triangle, one of those two angles is going to be greater than the leftover, and therefore it can be excluded. In the case where there's no triangle, we're going to get a domain error, which I'm going to show you an example of. Okay, so there are two angles out there in the world whose sine is 0.905, and we have to consider both of them. So what I do now is I call this one beta 1 and this one beta 2. I told you this was the hard example first. So here's what we got. We said that A was equal to 12. We said that B was equal to 31. C is we don't know yet. Alpha was 20.5. Beta 1 is going to be 64.8, which makes gamma equal to, we can easily find that one. That's going to be 20.5 plus 64.8 minus 180. What's the leftover piece? 94.7, you are correct. 94.7. So really all we got to do is get this piece, the C. Now on the other side, I'm going to have A is going to be 12, B is going to be 31, C will be, I don't know. Alpha, it stays the same as 20.5. Beta 2 is going to be 115.2. Therefore, my gamma is going to be, Daniel, how much? 44.3. So all I really need to do is get this one. So for each one, all you got to do is get the C, because that's the easy part. So we go back and set up a lost sign. Sine 20.5 over 12 equals sine 94.7 over C. Therefore, C has to be 12 times the sine of 94.7, all divided by the sine of 20.5. So C must be 29.4. Anybody get that? 29.4? Okay, good. On the other side, we set up and we get C is equal to, I'll just tell you what we get. Oh wait, I didn't get that at all. That's not right. That's not 29.4. What is it? 34.15. On the other side, C is going to be 23.93. Okay, so here is why ambiguous case does not work. Here are two triangles in which you have a side, and an angle that are all the same. But these are two completely different triangles. There's no way that they are congruent to each other. Because you have an angle, a side, and a side, and I don't know, gamma is I don't know. Here's the setup. So we're going to say, all right, well, the sine of 42 degrees divided by 22 equals the sine of beta divided by 12. So before we begin, though, here's my triangle. Here is 22. Here's 42. Here's 12. Here's beta. Here is C. Here is lambda. So 180 degrees total minus 42 that's already taken leaves me with a grand total of 138 degrees left over. You guys follow? Okay. So then I go over here and I say, okay, well, that's going to be 22 times the sine of beta equals 12 times the sine of 42. Divide by 22s, divide by 22s. Therefore, sine beta has to be 0.365, right? So beta is inverse sine of 0.365, which gives me, thank you for helping me out, 21.4 degrees. Or, if I take 180 minus the 21.4, that gives me 150. Yes, 158.6. And check it out. There's no way that it could be 158.6. How come? Because I don't have that much left over to divvy out between the two angles, do I? So therefore, it cannot be the case that 158 is the correct angle, so I'm sticking with the 21.4. These are much easier because you go back here, and that must be 21.4, which makes this one a grand total of 116.6, if I did that right, yeah. And then all we have to find is the C. You guys follow? Okay, and that one would be, that one's 29.4 when it's all said and done. Okay, and then let me give you the last example here of no triangles. Okay, a lot to take in today. So the A is going to be 15. B is going to be 25. C is, we don't know. Alpha is 85. Beta is some stuff. And gamma is some stuff. Okay, so we have 180. Whoa. I have 180 total. And I know that I have 85 being taken so far. So what does that leave me with left over? 95 degrees left over, which is not very much. So check this out. Sine 85 divided by 15 equals sine beta divided by 25. So sine beta must be 25 times sine 85, all divided by 15. Is that true?
1.66.
So the sine of beta must be 1.66. Therefore, beta must be inverse sine of 1.66. Now, whenever you get a number that's bigger than 1 or less than -1, you're going to get a domain error because it's outside of your range for sine, which means it's outside of your domain for your inverse sine. So when you plug this into your calculator, it gets really mad at you. So you have second inverse sine of 1.66. Says, hey, go away. You don't know what you're talking about. Therefore, you cannot even have a triangle exist. So no triangle exists, and you're done with the problem. You don't have to go any further. So I've scaled it for you. I gave you the hardest one first, the normal one, then the easy one. And you'll have to be responsible for knowing all 3 of them. But I'm not going to make you do 50 problems of the hard ones, okay? Any last questions or thoughts or ideas? Good, because I have something to show you after this, okay? So